Thank you. Hello everyone. I'm Xueming from TU Delft, and my topic is about particle sensing for portable devices. And this is the work collaborated with my colleague in China. During the past 3 days, I guess everyone has the great impression that more and more people are using big data to build like a sensible city, to make to deal with the pollution or something, to either for either for individual use or to deal with the pollution. The background behind this is that pollution is becoming more and more serious. So in order to deal with this pollution, we need to measure it, of course. In order to characterize the pollution, one of the most important indexes is called PM2.5. It's shortened by particulate matter, which is with the size of around 2.5 micrometer, or a bit smaller. And these kind of materials are from dust, dirt, smoke, etc. And the bad effect is that it will bring bad effect on climate, or for human body health, or for vegetation. And there are 3 different main ways to measure this kind of pollution. We can either use beta attenuation, or use resonation, or use light scattering. But for this kind of for these 3 different kind of ways, most of them are very bulky or very expensive, which is definitely not very affordable for personal use, and it's also not very easy to carry wherever you want. So imagine that you are living in a very highly polluted city, and you want to go out for a workout. So you might probably want to avoid this kind of high polluted area. So it's very necessary to get a real-time detection about air quality, so that you can avoid this kind of polluted area. And the point is that we want to integrate this kind of detectors in your, maybe like your watch or your phone, or maybe just in your pocket, so that you can carry it everywhere you want. And also, it's very necessary to make it very affordable. So when it comes to this kind of features, we would think about MEMS technology. In the reported work, we can find some work about using resonance to detect the particles deposited on the membrane, or use high voltage to charge the particles, so that you can measure the current from the device, so that you can get the information of the particles. But these kind of devices are like for the membrane, for when you want to check the membrane mass of the particle. After several times, you cannot use it anymore, because lots of particles are deposited on the membrane. And for this kind of high voltage devices, it's not so safe to carry such a high voltage device on your hand or pocket. So let's think about another way. So here we want to use the light scattering way to detect the particles. Here's the principle of the work. We first we have a measurement chamber with a light source and photodiode. So when there is particles going through the measurement chamber, the light will be scattered by the particles and then go through the photodiode. So in this way, we can get the information of the particles from the photodiode we measured. And here we have some simulation work about this measurement chamber. When there is no particles in the chamber, there is very limited light can reach the photodiode. We can see from these 3 different rays. The red one is with very limited attenuation, and the blue ones is almost with 60% or even higher attenuation. So the photodiode can hardly get some information of the rays. And when there's particles in the chamber, there will be light scattered directly go through the photodiodes. So in this way, we can use the light scattering to measure the particles. And this is a device we designed. We have two different dyes. The top die with the laser diodes as a light source, and there is a cavity so that the air can flow through. And there's a bottom die, so that's we have a photodiode for the detection, and the air can flow through. Oh, sorry. And we used a very standard processing for this kind of fabrication. We first use scale edge etching for the cavities, and then we deposit some silicon nitride to build up an anti-reflection layer so that we can absorb straight light to enhance the signal-noise ratio. And also we spot the aluminum layer for for the contact, and do the re-etching for the holes, and then aluminum patterning and wire bonding for assemble the optical components. And also we have the packaging. This is the device we fabricated. We have a PCB for the readout circuit, and also this is the silicon wafers. This is the bottom die with the photodiode here, and this is the measurement chamber. And this is the top die with the laser diode and the contacts. In order to measure to prove the concept, we use tobacco smoke to detect it. And tobacco smoke is with size of like 300 nanometer, and it's typical particulate matter. So in our work, the tobacco smoke is around 300 microgram per cubic meter, and we put the device in the clean air and also in the tobacco smoke, and we can get the different signal from the photodiode, and basically the voltage difference is about 50 millivolts. So this in this way, the responsibility of this device is around 0.183 millivolts per microgram per cubic meter, and the signal is around 5% higher than in clean air. And the deviation of the signal is around 6 millivolts, so you can get the limit of detection of around 32 microgram per cubic meter. We can see from this data that the limit of detection is not so great, but at least they can indicate that there is polluted air or clean air. But we have some problem with the laser diodes, because the angle of the light is so wide, so that we get very high noise of this. So so to sum up, we detected the particles based on we build our particle detection based on MEMS, and it's with light scattering method. And we measured it with tobacco smoke, and a limit of detection is around 32.7, and the fabrication method is unsophisticated. For the future work of this work is to first simplify the measurement chamber so that we can enhance the signal-noise ratio, and also to integrate the photodiodes in this chamber so that we can avoid so many mismatch during the assembly. And also we would like to integrate some optical devices like filter and collimator to avoid the the bad effect of the laser diode. And I would like to thank for the funding and also my colleague in Limas and also in Changzhou. And I would like to answer your questions. Thanks.